morning show from your local news leader.
Welcome back to the morning show.
And it's Wise Guy Wednesday, and Mats Selen, physics professor from the U of I, joining us today. So, Mats, what are we learning about today?
Well, I am excited to be back.
Yeah, we're excited to have you.
And I want to answer questions that people send in. And so Steve Swisher sent in a question, which was, what causes some elements to float and others to be heavy? And, for example, hydrogen and gold. So that is such a loaded question that we could spend weeks and weeks on. So we're just going to pick a couple of things in there. We're going to talk about why things are heavy and light.
Okay.
And why things sink and float. So that's what we're going to do today.
Perfect.
Okay, and so let's do the heavy light thing first. So now, everything is made of atoms. Okay? Now, an atom has a big cloud of fuzzy electrons around it, and then it has a nucleus in the middle. And the nucleus part is really, really small. So if the atom were the size of this room, the nucleus would be the size of a grain of sand. Really, really small.
Okay.
But that nucleus is where all the mass, the weight of the atom is located. And so what's in a nucleus are just protons and neutrons. So the weight of an atom just depends on how many protons and neutrons they have.
Are in that nucleus.
Inside the nucleus of the atom. So, for example, and all protons and neutrons are the same. So inside a hydrogen, there's just one proton, so it has a weight of this one. Inside a gold atom, there's 197 protons and neutrons. Okay, so it has almost 200 times the weight per atom that hydrogen does. And it's just because of what's inside this tiny, tiny little nucleus inside it.
Okay.
Okay, now, why things float and sink has to do with density. And density is how heavy something is or how much mass something has for a given volume.
Okay.
So, for example, we know that if you put a piece of wood in a swimming pool, it'll probably float to the top if it's a pine or something like that. That's because the density of pine is less than the density of water. So I want to do a little experiment for you guys. This is something you can do at home. You can do an experiment about floating and sinking in liquids. So inside this little jar, I have mineral oil, which I just got at the drugstore. It's like a laxative. So while that picture is settling in your mind, I have mineral oil in here. And then in this cup, I just have some water.
Okay.
That I put 1 drop of food coloring in.
Okay.
And
so just water.
Just water.
Okay.
So I'm going to pour the water into this thing. And you'll notice, because water is more dense than the mineral oil, the water goes and sits on the bottom. And oil and water don't mix. So what this means is that they separate really nicely. And so the lighter stuff, which is the mineral oil, sits on top, no matter how I turn this thing. And the heavier stuff, which is the water, sits on the bottom.
Okay.
And that's how floating and sinking works. And I've made a few others of these, and you can make these at home real easy just with a jar. They're quite beautiful.
They are.
This one has a little piece of hot glue stick in it. And it just so happens that hot glue stick has a density which is in between water and oil.
So cool.
So it kind of lays there at the interface, and you can make this little wavy thing. And it's really cool, right?
That is cool.
So that's with liquids. Now, with gases, the same thing happens. Do we have a minute left?
Yeah.
Okay, good. So here I'm going to make some carbon dioxide gas.
Okay.
And
so distilled vinegar.
I'm just getting some vinegar in there. I'm going to pour some baking soda in there. Okay. Now, when you mix vinegar and baking soda, you get a mess, but also you get carbon dioxide.
Okay. Ooh,
And so,
fire.
Yeah, a little bit of fire. It's okay. And so what I'm going to do is light this candle. And carbon dioxide is heavier than air because carbon has a, well, okay, so I'm going to pour, this thing now has carbon dioxide in it. I'm going to pour it on the candle. See how the candle went out?
What?
So you couldn't see it because it's the same color as the air around it, but carbon dioxide is actually more dense than air. And since it's displaced the air,
So it pushed the air down and
pushed the air out of the way, and so inside there's no oxygen, so the flame just goes out. Okay? So,
cool.
now, what happens with gases, is that here I have a balloon that has air in it, and I have a balloon that has just helium in it.
Okay.
And so if I let these go, the helium balloon goes up, and it's going to sit there until it pops. The other balloon goes down.
Okay.
And it's because helium has less density than air.
So it rises.
Yes, and so in fact, gases have a property that if you have the same temperature and volume and pressure, then you have the same number of molecules. So inside of both of these balloons, there was the same number of molecules. Helium has an atomic weight of just 4. And air has an atomic weight of around 28 or something like that. So it's maybe 6 or 7 times heavier than the other balloon, the gas. And so what happens is, therefore, it's not that helium wants to go up, it's that the other gas is heavier and it just wants to go down underneath the helium. And so that's what pushes the balloon up. It's pushed up by the other stuff. It doesn't go up by itself.
All right.
Okay. So I got one more thing, or we got it out of time?
Ooh, I'm waiting for the.
Let's go
waiting
for
the
it.
signal.
Go for it. Here you go.
Okay. So what we're going to do?
We're gonna do it.
We're going to do it. Okay. So I'm going to make some carbon dioxide here. This is something you can do at home, so I want to do it. So I'm going to put some carbon dioxide gas in here by doing the vinegar baking soda trick again. Okay. So there we go. So we have carbon dioxide gas. Make a little more of this. Okay. Then I'm going to take some bubbles. So now this thing is filling up with carbon dioxide. I'm going to take this little bubble thing, and I'm just going to blow bubbles.
Oh.
See how they're floating in there?
That is cool.
They're kind of, so the bubbles are heavier than air because it's air surrounded by a little bit of more mass of this bubbly foam, but
That's cool.
they're still less dense than the carbon dioxide gas. So the bubbles that go in there, see how they float?
Yeah.
Isn't that
Very cool.
Okay, so maybe next week I thought we would talk about how we know there are atoms, and I wish people would send lots of questions in because that's how we're going to keep this thing going.
Very
All
good,
right.
Mats. Thanks. If you want to send that question, just head to our Morning Show Facebook page, and you can put it there. We'll be right back.